Welcome to the next chapter, Permutations and Combinations. One of the most common questions in mathematics is, how many different ways can something be arranged or selected? Imagine you have a suitcase with a 4-digit number lock. You remember that the first digit is 7, but you've forgotten the remaining 3 digits. How many possible combinations do you need to check? One approach is to write every possible arrangement one by one. But as the number of possibilities increases, this method becomes extremely slow and impractical. So, is there a smarter way to count without listing every possibility? The answer is yes. And that is exactly what this chapter is all about. In this chapter, we learn powerful counting techniques that help us determine the number of possible arrangements and selections quickly and accurately. These ideas are widely used in mathematics, computer science, probability, cryptography, and competitive programming. The first concept we'll study is the fundamental principle of counting. Let's understand it with a simple example. Suppose Mohan has 3 pants and 2 shirts. He wants to wear 1 pant and 1 shirt. How many different outfits can he make? For the first choice, he can select any one of the 3 pants. After choosing a pant, he has 2 choices for the shirt. So instead of writing every possible outfit, we simply multiply the number of choices. We get 3 multiplied by 2, which is 6 different outfits. Now let's make the situation a little bigger. Suppose Sabnam has 2 school bags, 3 tiffin boxes, and 2 water bottles. She wants to carry one item from each category. First, she has 2 choices for the school bag. For every bag, she has 3 choices for the tiffin box. That gives 2 multiplied by 3, or 6 possible combinations. Finally, for each of these combinations, she has 2 choices for the water bottle. So the total number of possibilities becomes 2 multiplied by 3 multiplied by 2, which is 12. Notice something interesting. We never listed all 12 combinations. Instead, we counted them by multiplying the number of choices available at each step. This idea is called the fundamental principle of counting. It states that if one event can happen in m different ways, and after that another event can happen in n different ways, then the total number of ways both events can occur is m multiplied by n. If there are 3 events, we simply multiply all 3 numbers. This principle works for any number of successive events and forms the foundation of this entire chapter. Let's see one more example. How many 4-letter words can be formed using the letters of the word rose if no letter can be repeated? There are 4 empty places to fill. For the first position, we have 4 choices. After choosing one letter, only 3 letters remain for the second position. Then 2 choices remain for the third position. And finally, only 1 choice is left for the last position. Applying the multiplication principle, the total number of words becomes 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. This example shows how quickly we can count large numbers of arrangements without actually writing every possibility. As we move ahead in this chapter, we'll build on this principle to study permutations, where the order of arrangement is important, and combinations, where only selection matters. Once you understand this counting principle, the remaining concepts become much easier to learn.